Welcome back to the Cambridge International AS and A level practicing in past paper and in question number 2 with the paper 3 advanced practical skills to for May June session 24. Today our appointment was the question number 2. What do we need to do here in this question? This question actually is a titration or a redox reaction titration. Redox reaction titration, as we know, we will make a titration or we will titrate the analyte or we will titrate something we don't know its concentration or we don't know its oxidation number with something else is oxidizing agent or reducing agent. Here in this question, what he's saying, iodate ions contain iodine and oxygen. Okay, fine. They have the formula IOX minus 1. So if we saw O minus X, so you have to predict, you will find X, where X is an integer. In this experiment, you will determine the value of X in the iodate. You will first react what? IOX, the iodate ion, with an excess of iodine ions, okay, I minus to form iodine. So the first step here in this question or in this experiment, we will do two experiments together in the same time. We will dissolve iodate ion with something it has iodate minus 1 to give us excess of iodine. Then this excess of iodine we will use the titrant, which is sodium thiosulfate, to titrate the amount of iodine which we prepared them from the iodate which we have, or the sample which we have, to know how many iodate how many iodine produced from iodate, which can tell us the concentration of iodate. Okay, so what do we need to do? First, we need to find the concentration of iodine, which we will produce it from reaction of iodate with something it has iodine minus 1, which is something like potassium iodide or something like that. Okay, so the amount of iodine produced in this determined by titration with thiosulfate ions is 2O3 minus 2. Okay, so what should we do here? The first step, we must follow up the instructions which given in this question. What are the instructions? The method, it's here. We call it scheme of work or the method of work. The FB1, it will be sodium thiosulfate, as we know, and as we see here, the concentration is 0.100, and all of our writing or all of our concentrations, all of our calculation, it must be in 3 significant number, as we said. So, for example, what's the significant number? We must write at least 3 numbers significant, and you know that, well, how can we detect that? So FB2 here is 0.0100 mole per decimeter. This is sodium thiosulfate. FB3 is a solution containing 0.0140 mole per decimeter of iodate. FB4 is diluted sulfuric acid, H2SO4, and FB5 is 0.5 mole decimeter sodium potassium iodide. Then we have starch indicator, and here in the starch indicator, in working, you must find your starch indicator as a translucent, is not turbid, or it doesn't have any accumulation of starch, and it is not clear. Okay, fine. So what is the first step we should do, and what the most important points we should consider in our working? First of all, we should draw the plan in our brain. What's the plan we should draw? Now we need to understand what should we do. We will make a titration or redox titration. So first of all, if you cannot understand the reaction, draw it. If you cannot understand the reaction, draw it. So what he is saying, he said fill the purite with FP2. Where is the purite? Let me draw the purite. Purite is here. Okay, and this purite we use it to titrate. Fine. This purite we will fill it with FB2. What is FB2? FB2, he said it's sodium thiosulfate, Na2SO3. Fine? Okay. Na2SO3. This is sodium thiosulfate. Then he said is a solution containing 0.014 mole decimeter. This is FB3. What he need? Pipette 25 centimeter, not cylinder, pipette with 25 centimeter of FB3 into a conical flask. Let me draw the conical flask with 25 centimeter of FB3. What's FB3? FB3 is our iodate ions which we need to work in it. Okay, and don't forget, before titration we must convert this iodate into iodine. Why? To titrate it with sodium thiosulfate. So we need this iodate to react with something to give us iodine, which is potassium iodide. So here, before this reaction, we must acidify this reaction, or we must acidify our solution by adding 10 centimeter of H2SO4, which is FB4. Okay, 10 centimeter of H2SO4. And here we will use what? We will use a measuring cylinder. Okay, we will use a measuring cylinder. So the first step, we will use a measuring cylinder to add 10 centimeter of FB4, which is sulfuric acid. Then with the same measuring cylinder, without rinsing, add 10 centimeter of FB5, which is a potassium iodide we needed to react with FB3 to produce what? To produce iodine. Now, by this reaction, what we did, we let the iodate to react with Ki to give us what? Iodine. What is the function of sulfuric acid here working as a catalyst? Fine. Then, after we did our reaction, let's go and follow up the instruction. Add FB2 from, now we finished, okay, and we added FB5. The cylinder to add 10 centimeter of FB5 to the conical flask. Then add FB2, which is sodium sulfate, from the purette until the solution turns yellow. Okay, is it the yellow color? Is it the end point? No, it is not. What is the end point? We didn't add till now the indicators. What is the indicator which we should use? The indicator which we should use is a starch solution. Now this yellow color, we add it, just we start to add sodium thiosulfate to let the reaction to start. Then add 10. After you find your yellow color, add 10 or 15, from 10 to 15 drops of FB6, which is our indicator starch solution. Then continue the titration, okay, with FB2 to form and to find. Now, by adding the starch solution, this yellow color will convert it directly to blue, black color. Okay, then start again to continue your titration till this blue black color just disappears. Okay, perform rough titration and record your purette readings in the space below. So here, this is the first reading and we call it rough titration. Okay guys, after in the first part we learned how can we make this titration and how can we find the rough titration and the endpoint. Now we need to know how can we write down our results in our paper. The most important point here, how can we draw and write down all of our results? We should put them in a table, and this table, it must be clear, okay, because you're writing in your numbers and your units which you will write, it's very, very important to detect it if it's your titration or your work is correct or no. So the first step here in this area, he said, try to record your results in a suitable form in a space below all your purette readings and the volume of FP2 added in each accurate titration. Okay, so now how can we draw this table? First of all, our table, it must be drawn by the ruler. Don't draw it by your hand. Okay, so let me draw my table first to know what should we write inside it. Here, this is our table, and we will try to divide it according to the number of titration which we need. So the first one must be bigger because we write here, then divide them 1 2 3 4, at least 5, like that. Okay, then the first one, this is the general, and here is the initial, and this is final, and here is our writing. So what should I write here? In the first one, we should write here, this is titration, because we will make more than one titration. Okay, the first titration is called rough titration. Rough titration. What's rough titration? We did it before and we wrote its answer here, or the result of rough titration here. Then we should write the titration number 1, titration number 2, Okay, titration number 3. And if you need to add number 4 or we don't have enough time, okay, don't include it. What should we write here? The first is one, it should be, we should write the initial reading, initial reading in centimeter cubed. Okay, and centimeter cubed here is very, very important to show the examiner your unit. Here this is final reading, okay, in centimeter cubed, and here this is the FB2 volume in centimeter cubed. For example, the rough titration, we found it, we should start from 0 because we filled our purette with titrant, so it should be 0 0 0 like that. Then after we finish our rough titration, we found our reading is, for example, 24.2. So how many centimeter did we use to titrate the iodate? Is 24.2. So the FeB2 volume here is 24.2 centimeter. Okay, then start to make your second titration. Should we write here rough titration? Yeah, it's very important to write it here to show him what is the initial reading which you take, and the second reading which you or the final reading which you recorded. Then start your titration or the second titration. If you will start direct your titration, so you should start here from 24.2, the end or the final titration or the final reading which we took it in rough titration. Then continue your titration and find the volume of FeB2. So for example, it will be 48.5, so it will be 24.3, for example. Okay, then the second one, if we found it now, this is the first one. Second one, for example, it will be 24.35, and here 24 point, for example, 40. Okay, so which one we should consider, which titration, which volume we should consider? We should consider the two titration which they have at least, or the difference between the two titration is not more than or less by positive or negative 0.1. okay, and take these two concordant numbers and divide them by 2 to find the average between them. All of them, they are correct. Okay, but for example, if we found us here the first iteration is 25, okay, 0.4, for example, and the rough is 24.2, the second one 24.35, and the third one 24.40. Don't try the first one 25.4. If you wrote it, it's okay, fine, leave it. Don't make too much correcting in your paper. Fine. So we should consider the two the last two titration. If you find yourself all of your titrations, they don't have at least two, the difference between them less than 0.1, so you have to record or to adjust your reading to be, or it had to have at least two titrations, they have between them a difference positive or negative 0.1. okay, so here in these readings, all of the titrants, all volumes, they are, or the difference between them 0.1. okay, can we find all of our titration results they are the same? Yeah, it can happen, why not, but it's rarely to happen. Okay, good. Now we found our titrants. What are they? 24.3 and 24.35 and 24.40. So if we take these two, 24, now we need to find the average. 24.35 plus 24.40 over 2, and write your volume here or the net result here. Okay, this is the titration result. Fine. How can we use them? Now we found, now it's 20, for example, we'll find it, it's 24.3, for example. Okay, then go to the second part. What is the second part? He will ask us the volume which we should write. Look at the second part. From your accurate titration, which we did before, result, calculate the suitable mean value to use in your calculations. Show clearly how you obtain the mean value. Okay, as I told you, we have to show him here now in 25 centimeter, in 25 centimeter of 25 centimeter of FB3. He asking about how many FB2 we did use. This is the correct or the most correct titration which we consider in our results. As I told you, you have to use two concordant numbers or two results, the difference between them less than 0.1. Okay, less than 0.1. Add them here, for example, 24.35 plus 24.40, okay, over 2, and write your result here as FB2, and we write the number here. Okay, now we found the FB2. Okay, this is the B. What is C? We will start our calculation. What's calculation? We finished the practical part and we will do some calculation. Give your answer to C2 and C3 and C4 to appropriate number. Insignificant, it must be 3 significant number, as we know. Use your answer to B and the information given to calculate the amount in mole of iodine formed when 25 centimeter. Okay, this is a volume. Reacts with 10 centimeter of FP5. Okay, now we need to know how many moles of iodine produced from this reaction. Okay, if I know the concentration and I need to know what? I need to know the number of mole. What is the number of mole? As I told you, you have to start from the end. But the number of mole equal concentration multiplied by volume. Do we have the number of mole? No, we don't have. We need to find it. Okay, do we have the concentration? Yes, we have concentration. It's the same concentration of 25 centimeter. But do we have the volume? We don't have the volume. But so we cannot use this to find iodine. So how can we find iodine? Don't forget we have a stoichiometric equation. What's the stoichiometric equation do we have here? The stoichiometric equation which we have before, or they told us about it before, is the ratio between iodine and sodium thiosulfate is 1 to 2, as we see here. Iodine is 2 and sodium is 1 and sodium thiosulfate is 2. So the ratio between iodine and sodium thiosulfate is 1 to 2. So now we need to know how many mole of sodium thiosulfate we used. If we know how many moles of sodium thiosulfate we did use, we can divide it by 2 to find the number of moles of iodine. Am I correct? Okay. So the next step now, we will try to find how many moles of sodium thiosulfate. Why did he ask about how many moles of sodium thiosulfate? No, he didn't. But we should know how many moles of sodium thiosulfate to try or to help us to find the number of moles of iodine from the stoichiometric ratio, which is 1 to 2. Okay, up to now is fine? Good. Now we will try to find the number of moles of sodium thiosulfate. From where the number of mole of sodium thiosulfate? The sodium thiosulfate from the ratio, the sodium thiosulfate from the volume which we found. So the volume or sodium thiosulfate is 2. Which is S2O3. Okay, sodium thiosulfate. How many sodium thiosulfate do you use? We need to know number of moles of sodium thiosulfate. Equal what? We know the concentration equal the number of mole over volume. Now we need to know the number of mole. Do we have the concentration? Yes. Do we have the volume? Yes. Where is the volume? The volume we found it from titration. Okay, and the concentration he gave it for us. So number of mole equal volume multiplied by volume by concentration. Okay, what is the volume? The volume is 25 centimeter, which we did start with it. Okay, and the volume of sodium thiosulfate, the volume of sodium thiosulfate, which we found them from the titration. How many? The number which we wrote it here. Okay, for example, if we found it, for example, it's 24.40 or 0.4. Okay, this is the volume. of titration multiplied by how many? The concentration. What is the concentration of sodium thiosulfate? Where is it? The concentration of sodium thiosulfate, we can find it from here. Sodium thiosulfate, it has concentration how many? The concentration is 0.1, okay, is 0.1 as we see it here. Look, this is the concentration of sodium thiosulfate, 0.1. Okay, again we will go to the our calculation, 0.100, okay, to find what? To find how many moles of sodium thiosulfate. Now the number of moles of sodium thiosulfate, the relation between sodium thiosulfate and the relation between the ratio between sodium thiosulfate and iodine is 1 to 2. Let me find by calculation. It's 24.4. Okay, it's 24.4 multiplied by 0.100 equal 2.4, okay, 5. What's this? The number of mole of, no, it is not correct. Something is wrong here. Oh yeah, listen, we didn't convert the volume to decimeter because the volume here is in centimeters, so we should divide them by 1000 before any calculation. So let me clear it. It's 24.4 over 1000 equal, now this is the volume. Our volume now is 0.024. This is the volume of sodium thiosulfate in decimeter which we did use. Okay, fine. This volume is 0.024 multiplied by its concentration, which is 0.1, like that, equal 0.002. Okay, this is a number of mole. Okay, number of mole here equal, what's this number of mole? This number of mole of sodium thiosulfate equal 0.002. Okay, this is the number of mole. All of this result, it may be not real because I just predict the titration. I don't know, it may be 13, it may be 14, it may be I don't know. Okay, this number I just predicted it. Okay, okay, 0.002. This is the number of mole of sodium thiosulfate. Now we need to know the number of iodine. Number of iodine, as I told you, is the ratio or the ratio between iodine and sodium thiosulfate. So this number of sodium thiosulfate, we can divide it by 2 to find the number of mole of iodine, as we said, because the ratio is 1 to 2. So here we divide it by 2, it will give us 0.001. Okay, this is the number of mole of iodine. Fine. Okay guys, let's continue the last part here in this question, and calculation of how many moles of iodate ions did we use in 25 centimeter of FeB3. Okay, so now we need to know the number of moles. It's very easy because you know the number of mole equal the concentration multiplied by the volume, and our volume is 25, so we should convert it into decimeter first before using. Let me do it here. So 25 over 1000 equal 0.025. okay, so now number of mole equal 0.025 multiplied by the concentration of iodate ion, which it was 0.0140. okay, it will equal, let me multiply them, 0.025 multiplied by 0.0140, it will give me, okay, the number of mole, it will be the 3.5 multiplied by 10 minus 4. Okay, how can we write it? This number, we need it without power. Why? To take the ratio, or to know how many, or the ratio between iodine and iodate ion, as we will see now in the next question. So we can write it like, yeah, the are 4 zeros, so 0.0123, okay, 3, 5, like that. Okay, because we will move the sign. Yeah, now they are 1, 1, 2, 3, 4. Yeah, it's correct now. 0.00035 mole per decimeter. This is the number of moles of iodine. Cool, guys, let's continue. The last question. This unbalanced equation for the iodate react with potassium iodine uh, to in acidic solution to give us iodine and H2O. We need to make balance. If he said balance, so we should write just numbers and we should know what is X. Okay, from the ratio between the number of moles of iodine, okay, between the ratio of number of moles of iodine, which we have here, and the number of mole of iodate, we can find the numbers. Okay, from the ratio, what do we have? The ratio between iodine and iodate is very easy. We found iodine as 0.001 and iodate is 0.0035. So the ratio between IO minus 1 x minus 1 e to I2 is what is 0.00035, okay, to 0.001, which it means, or if we divide both the big one and over the other one, we find the ratio is 1 to 3.5. Okay, so we will start now to make our balance. So now we are sure the number of moles of iodate is 1. Okay, and now we need to know how many moles of iodine. From the ratio we can say the number of we cannot write 3.5, so it may be 3 or 4. Okay, so let's say it's 3. Okay, and let me write here 3 iodine. Okay, so if we said this is 3 iodine and here 1 iodine, so how many remained from the 6 iodines which we wrote them here? 3 multiplied by 2 equals 6, so the remaining iodine should be 5. So iodine here should be 5. Now we need to continue our balancing, but we cannot continue the balance without knowing how many x's. Okay, so we should assume starting from 1 till 7 or till 6 to know 1 or 2 or 3 or 4 and write the equation and try if it's correct or no. So the correct one or the correct answer, let me tell you, it will be 3, and inshallah in the session I will explain how can we find the x or how can we assume it correct from the first time. Okay, if we assume it is 3, okay, now how many oxygen did we use? 3 oxygens. 3 oxygens here, and here we have H2O. So how many H2O do we have if we have here 3 oxygens? It must be 3 also. Okay, 3 multiplied by 2 equal how many hydrogen? 6 hydrogen, so we should write 6 here. And now the equation is balanced equation, and the ratio between iodate and iodine, we should write it 1.3.5 as we found it, and X here is 3, assumed as 3. Okay, should we write all of equations which we assumed? Yes, we can write the equation which assumed in the blank paper, or we can neglect it, or we can just write the assumed or the correct assumed number, and we should detect it here and write it as a result. That's it, and now we finished the question. Please listen carefully for these videos. If you found yourself you don't understand anything, please ask me before Monday, because we need to repeat this session at least, or this experiment at least 2 times. We will not gonna repeat it. We will not gonna, or we cannot repeat it. As you know, we don't have enough time, and we have a lot of experiments we need to practice it, and then we will continue. Thank you so much.